Okay, we're live. Hello, everyone, and welcome. It's actually been a while since we've had our last virtual jug session, and I'm really excited about this one. This is going to be a good session. It's going to be it's actually a very well RSVP'd session, so this is going to be hopefully getting a lot of viewers. So let me introduce our speaker, Nic Raboy from Couchbase. How are you doing, Nic?
Doing great, thanks.
And welcome. This is your first time on the virtual jug. One of your colleagues, Arun Gupta, is very well versed with the virtual jug. Obviously, he's been on there a few times, but this is your first time on. How are you looking forward to it?
I'm looking forward to it big time. Yeah, it's my first ever virtual meetup at all, not just the virtual jug. Yeah, so
It's interesting. A lot of people. We have to ask you afterwards how you found it, because a lot of people find it quite disconcerting speaking to a monitor with no feedback. But we'll see how this goes.
yeah, I like talking to myself.
Right, cool. Okay, so let me quickly share my screen, and we'll show everyone what's going on today. Keynote, there we go. Okay, here's the session then. You can see my screen?
Yeah, I see it.
Perfect. So this is full stack development with Java and NoSQL, and our speaker, as I mentioned, is Nic Raboy. You can follow Nic on Twitter at @nraboy. Yeah, please do follow Nic on Twitter, and if you do have any questions which we don't have time to fit in this session, you're more than welcome to tweet Nic there as well. The session is sponsored by Zero Turnaround, and a lot of our sessions have write-ups and all the links on Rebel Labs on one of the blog posts there, so do check that out as well. A little bit about what Zero Turnaround do. They create revolutionary tools for developers, and a couple of those are JRebel and XRebel, and you can check out that more on zeroturnaround.com, and you can grab some free trials of each of those products. So the virtual jug today, if you wanted to ask questions or have discussions, you can go to hash or pound virtual jug on Freenode IRC, and you can ask all your questions there, and I will ask them directly to Nic. We'll be taking questions after the session today. Please do share the session group, tweet about this session right now, and we'll get lots of people on live. And if you have any feedback, of course, about any of the virtual jug or the session, feel free to either tweet virtual jug or myself there at SJ Maple. And one final thing that we will mention actually before we go live. Let me stop the screen share. Before we go live, on the bottom right of this screen, where is that? Is that going to be here or is that going to be here? I think here maybe. Yeah. There is a little cog and a little kind of like settings cog. If you click that and then choose your screen resolution or video quality, change that up to the highest possible. 720p is normally there, so if you click that, you'll be able to see Nic's screen, particularly when we go drop into code, a lot clearer. So I think that's pretty much it. Without further ado, actually there is one kind of thing. I'm gonna give you a very, very sneak preview about something. We're going to be announcing something, probably one of the biggest things that we've announced on the virtual jug. Probably next week I'll be sending out an email to that, and it's going to be one of the biggest sessions, plural sessions that we've ever done. So do keep an eye out for that next week. There's a little teaser for you. One other thing is we've got James Gosling on the Java Council podcast, and that'll be being recorded next week. So I hope to get that out towards the end of next week. So do check that out. And that's about the Java EE Guardians, if you've ever heard of that, with Reza Raymond. So all that to look forward to. But right now we're going to be talking about full stack development with Java and NoSQL. So I'll hand over to yourself, Nic, and let's get underway.
All right, perfect, Simon. I'm gonna share my screen now.
Cool.
Oops, wrong button. Are you able to see my screen?
I am able to see, yeah.
All right, perfect. All right, so you're here for this virtual jug because you want to learn about full stack development with Java. So our stack is going to include, of course, Java. It's going to include a flavor of NoSQL. It's going to include Couchbase in particular. We're going to use AngularJS as our front end, and then we're going to extend this to mobile while still using Java. So we're actually going to be using Android. So first off, because many of you, this may be your first time hearing of me. So my name is Nic Raboy, and I'm a developer advocate at Couchbase. I actually work in San Francisco, which is in the United States. Like Simon mentioned, you can follow me on Twitter at nraboy. I definitely encourage you to ask me questions there. And if there's for some reason I can't answer your question at the end of this meetup, please definitely reach out to me. As far as my skill set goes, I am proficient with Java, Node.js, and then a lot of the mobile technologies like native Android and then say Apache Cordova. So since this may be your first time actually hearing of Couchbase or maybe NoSQL in general, I do want to give a background since this is going to be the database that we're using for our application. So Couchbase is actually a distributed database that lets you develop with agility and operate on any scale. So this is made possible because Couchbase actually has a managed cache layer. So what happens is when you're inserting documents or when you're reading documents, you're doing so via the cache. And then asynchronously, it'll actually be persisted to the disk layer, or if there's no room inside of your cache layer, because RAM is always smaller than disk, cache will actually be ejected in order to read from the disk directly in case that data doesn't exist in the cache already. Couchbase is actually a key value store and a document database. So much of the documents that you'll be storing in Couchbase are going to be in JSON format, and they're going to have a flexible schema. Couchbase actually extends beyond just server, so you actually have an embedded Couchbase version, which we're going to go over towards the end of this presentation. But when you combine the mobile embedded edition with the server edition, you can actually synchronize between the two with what we'll talk about. It's called sync gateway. So there's sync management included in Couchbase. And of course, this is all open source. So I encourage you to check it out at the end of this. So where is NoSQL a good fit versus, say, a relational database? NoSQL is good in web, mobile, and IoT, particularly with modern applications. I say modern because modern applications tend to need to be able to handle massive amounts of users and massive amounts of data. This is data that changes rapidly. So being able to work with a schemaless data set is definitely more convenient than working with a relational database with constraints that you have to consistently update. Where a legacy database, so a relational database might work best in legacy applications. So maybe you need full asset support. Maybe these are transaction-heavy apps. Maybe stick with a relational database in that case. So again, there's really no one database fits all scenarios. It's pick the database that best fits the needs of your application. More in terms of NoSQL and Couchbase. So Couchbase allows for easier and faster development. So I mentioned just a second ago that with NoSQL, you don't have to worry about modifying your relational database. You wouldn't have to modify any columns or tables because there is no schema in NoSQL. You can just add these properties in as you see necessary, and that goes with the flexible data model. Couchbase in particular has powerful querying, so you can do direct lookups based on key. You could work with views, or you could even use a SQL-like language called Nickel, which we'll be using heavily throughout this example. Couchbase actually works with a lot of big data integration tools like Apache Spark. I'll go more onto that in the next slides. But it also works well, of course, with mobile and IoT. So an example is I actually started working with an IoT project. I actually started working with an Intel IoT device, an Intel IoT gateway, and I actually installed Couchbase on it, the Couchbase mobile edition, and it allows me to keep track of data and then synchronize it with Couchbase Server as I deem necessary. More on Couchbase and its ability to scale. So with Couchbase, it's a horizontally distributed system. So if you need to add more data, if you need to add more memory to your system, if you need to add more processing power, you would scale it out. You would add more nodes to your versus a relational database where you'd actually be scaling it vertically, where you would add more memory and hard drive space to a single server, making it very expensive and hard to maintain. Couchbase offers consistent and high performance, and it's always on availability. So if you need to add and remove nodes to your cluster, you can do this while keeping your database online. You don't need to bring it offline in order to do this. Couchbase has a very simple administration dashboard. It allows you to do a lot of great stuff. I'm going to be showing you a live preview of that in just a moment, but Couchbase also offers enterprise-grade security as well. So more on Couchbase from a developer's perspective. So Couchbase actually supports pretty much all of the popular programming languages. I know this is a Java presentation, but if you wanted to use Node.js, PHP, Go, you certainly could. It supports pretty much any framework that you want to use. It's not framework specific. So for this example, we're going to be using Spring Boot, but if you wanted to, you could extend it to say Ratpack or something else. You could bring it to the mobile platforms. You could use it on different flavors of Linux, Mac, Windows. You could even install it on services like Amazon Web Services and Joyent. So more on top of the big data stuff. So I mentioned Spark, but you could also use it with services like Kafka. You can use it with big business intelligence tools like Informatica. You can use it with Cloudera. So there's a lot of different big data integrations that you can use with Couchbase. So I know that this is a developer presentation, but I know nowadays everyone plays the role of DevOps. So at some point in time, you're probably going to find yourself needing to manage the database. If you find yourself managing Couchbase, lucky for you, every node that you install of Couchbase and add to your cluster is going to be exactly the same. So there's no independent configurations that need to be done. So that caching layer, that persistent disk layer, you're not spinning up two different nodes to accomplish that task. Every node is going to have a data service layer, indexing engine, query engine, and a cluster manager. Now you could do what's called multi-dimensional scaling and scale each one of these services differently. So I mean, you could say this node is specifically going to process data, or this one's specifically going to be a query node. But from a configuration and a setup perspective, they're all the same. You just tick a different checkbox inside of the dashboard, and you're good to go. Here's that simplified administration panel. This is just a screenshot, but I will be showing you an actual demo of it shortly. But inside this administration dashboard, you can actually view stuff like what kind of load is going on with your cluster. You can see if all of your nodes are online. You can view your data. You even have access to perform HTTP requests against RESTful APIs within Couchbase. So this is more on the flexible JSON model. So I mean, this may be new to a lot of you, but on the left is a relational. Let's say this is a relational set of tables, and on the right is the NoSQL form. So say we have these three tables. There's actually different ways you can convert these into NoSQL format. So one way is, well, the user skills and user experience. A lot of the time, you're going to be querying these three tables at the same time. You're not going to be querying them independently. So in NoSQL, well, why not just store those all in the same document? If they're going to be accessed at the same time, might as well maybe just store them with each other. That's one way you could store your data. With NoSQL, you don't need to normalize your data. So if you have duplicate data, that's perfectly all right. Another way you can do it is, if you want to keep the more relational approach, is maybe each one of these tables has a primary key, and then some of the tables have foreign keys. So if you wanted to, you could actually refer a relationship in NoSQL. So you can actually store a property that references a primary key to another set of data, and you could still do your stuff like that. But there's no defined constraints, so it'd be all up to you as a developer to maintain that, and that's a perfectly acceptable approach as well. So as far as querying and accessing data from Couchbase. So I mentioned this briefly already, but I'll go over it in a little more depth. So you can actually access your data through CRUD operations. So you could take your document ID or key, and you could do lookups, and these lookups are very fast because you're getting that document directly. And reads and writes are actually, so you're working with a distributed system. You're working on a cluster, but when you write data, the cluster map as part of the SDK will actually, it'll keep track of where that data is written. So that makes your reads and writes very fast. If maybe you don't want to work with the key directly, you can actually use view queries, which are MapReduce queries. And they're good for custom aggregations, or like I said, maybe you don't know the document ID. You can create your own view, and then you can query it based on the logic that you define in the view. Or which is my personal favorite, because I actually come from I used to work in higher education, and I used to work with Oracle a lot. So I used to be more familiar with a relational database, relational SQL, than I was with NoSQL. Couchbase actually offers Nickel, which is a SQL-like language. It allows you to run SQL queries against this complex JSON data, which is really convenient, especially if you're coming from a relational database world. So you get that power of SQL, but then you get extensions towards that JSON data, because JSON is very complex. If you didn't want to use the SDKs, which I'm actually going to be focusing on the SDKs, but if you didn't want to use the SDKs, maybe you have this legacy application that uses a JDBC driver. Couchbase actually does offer JDBC drivers as well. All right. So as far as the Java SDK goes, so now we're going to get more into the developer-focused stuff. So the Java SDK is actually it actually has synchronous and asynchronous interfaces. We're going to be focusing on the synchronous stuff to start, and then we're going to work on more of the asynchronous stuff using RxJava, which many of you might be familiar with. Like I said previously, the Java SDK is compatible with various Java frameworks. So I'm going to be focusing on Spring Boot, but maybe you want to use Ratpack, maybe you want to use something else. That's perfectly fine. The SDK allows for minimal coding, and that's in two senses. So I mentioned it, one of these briefly already, but there's no database maintenance inside of your code. You don't have, if your data changes tomorrow, you don't have to write upgrade scripts inside of your code to add these new columns or alter your tables or anything like that. You just add the data or you remove the data. It doesn't really matter. The other perspective on minimal coding is the way that you query your data. So if you've ever worked with the NoSQL database before, you know that querying can be complicated. There's a lot of application code involved in order to massage your data into something that can be returned to the user. Because we're using Nickel queries here, we're actually sending our query with the exact data that we want to be returned to Couchbase. Couchbase will do all the crunching, and we'll get the data in the exact format that we requested it. So it minimizes a lot of the coding. And that's something that you guys are already familiar with through, I mean, a lot of you are already familiar with through relational databases and Java. So here's what it would take to get started with the Java SDK inside of your application. So the first thing that you would do is you would connect to a Couchbase cluster. Here's an example. I'm only connecting to one node in this cluster. This is something that you typically would not do. You wouldn't do this because if that node goes down, your application kind of fails. So typically you would pass it a list of nodes, so several nodes in your cluster, so that way if there's some kind of failure, you can connect to a different node. So once you have your connection to the cluster, you can then open up a bucket in that cluster. So a bucket is a collection of NoSQL documents. You can have documents spread across multiple buckets. You could have all of your documents in one bucket. It's up to you. We actually do recommend that for every app, you create one bucket per application. So you could have 100 different types of documents, but they would all exist in that same bucket. And then you could supply an optional password as well. So with your bucket open, then we can start performing operations on it. So in this case, we're going to create a document. So again, these are JSON documents, so it's different. You're not working with rows and columns. So what you would do is you would create this JSON object. In this case, we only have one property in this JSON object. The property is name, and the value is John. Once we have this JSON object created, we can go ahead and create a JSON document. In that JSON document, we provided a key value. So your key value could be pretty much anything. It could be something that you can remember, so human readable. It could be uniquely generated. It could be a mixture of the two. That's a completely different topic on key generation, but it's really what best fits your needs. So you would create this key, and then you would go ahead and add the JSON document to that key. And then when you're ready to save it, you can call bucket insert, and it'll create that document. You also have the ability to do upsert. You can delete, you can do get, you could do all of the CRUD operations that you would expect. This is an actual typical Java function, at least typical for the application that I'm going to be demoing. So we have this function, doesn't really matter the name, let's just call it function, but it returns a list of maps. And then this list of maps will be returned to the front end through some kind of JSON. So we have this function, we pass it in a bucket, the bucket that we've opened, and then we want to perform a query. This is a simple query. We're selecting all properties from all documents in a particular bucket. So a pretty standard query here. This query is a string so far, so what we have to do is we have to parse it. We have to parse it into a NoSQL query. So we're calling NoSQL-query.simple, and then we're calling bucket.query. And then remember, so far this is synchronous. So once it finishes, we're going to check to see if the query had failed. If it failed, we're going to return that to the user, or whatever called this function. If it succeeded, what we can do is we can actually loop through the results and add them to that map that we plan, the list of maps that we plan to return. And then we finally return that content back to whoever called it. Here's a little bit of a more complex NoSQL query. Let's look at the actual query string first. So here we're actually selecting, and we're unioning two data sets together. This is something that would probably be pretty difficult if you're using a different NoSQL technology. Not so difficult if you're using a relational database, but it's particularly useful for NoSQL because you're working with complex data. What's also different here is our use of, you notice that we're using $1 and $2. Those are actually parameters as part of our parameterized query. And we're using parameters because we're accepting user input. And just like a relational database like Oracle or MySQL, Couchbase can actually fall victim to SQL injection as well. So we want to parameterize our queries so that way we don't get any kind of injection attacks. So we're passing it into this, instead of we're using NoSQL-query.simple, we're using a parameterized query. We're creating a JSON array. We're adding the parameters to that array in order, and we're executing the query and returning the results. So I'm going to show you a demo after I get a drink of water real quick. All right, so this, let me find it in my computer here. So this demo is probably one of the most simple demos you'll ever see, but it's a common demo when you're learning a new technology and data stack. So what it is we're essentially looking at an application that will allow us to add new users to a list. It'll allow us to edit those users, and it'll allow us to delete those users. So I actually have a locally running Couchbase instance on my Mac, and what I'm going to do is first I'm going to add a new user. So I'm just going to walk through it real quick. It's pretty basic though. So I'm going to add Maria Raboy. She's my wife. Hit save. So she has now been added to this list. Now let's say I want to edit. So I know it's probably small for many of you on the screen, but there's actually a key in my URL bar. This key is the document key, and it allows us to do a lookup to populate this form. But let's go ahead and change my name to my short name. save it, and it's now saved. And finally, I'll go ahead and delete Maria from the list, and she's now deleted from the database. So let me go ahead and look at this database right now. So this is actually the Couchbase administration dashboard. When you first log in, you'll get something that looks like this. It'll tell you, of course, I only have one node. It's a single node cluster. But it'll tell you the operations. You can actually also, what we care about is we're going to look at the data buckets. I have several data buckets, but this particular application saves it into RESTful sample. So if I click on this, I only have one document inside of this particular bucket, the one that you just saw, my particular document. So if I click it, this is what the data would look like. It's very simple. I've got my key here, and then I have the data that I saved. So very simple. So now I'm going to walk through what happened in this demo. Oh, and it seems to have started from the beginning. So let me figure out where I was real quick. All right. All right. So the application that I just showed you, the very simple one, it was actually separated into two parts. So AngularJS is the front end, and that includes both AngularJS, HTML, and CSS for styling. But the backend was split up into a separate application, which is Java and Couchbase. So why did I split those two up? Well, I split it up because it makes it more API driven. Instead of piping your data into your front end, we're now making requests against the back end. So we're making HTTP requests from AngularJS to our Java backend. And that in turn makes it so that way there's less client and server coupling. And it allows your backend to be able to evolve without affecting the front end. So maybe you need to do some maintenance on your backend. As long as the data doesn't change, your front end will be fine. An example of this, so I actually have this same exact demo, but I actually have it for Node.js. I'm actually using the same exact front end. The only thing that's changed is the back end. Or I could do it the other way around. If I didn't want to use AngularJS, I could switch it to React.js, or I could switch it to something else because the data won't change, and that's fine. I also have the opportunity to extend the front end to other platforms. So maybe I also want to extend it to mobile. I can certainly do that. Maybe I want to extend it to my thermostat, or I want to extend it to my gaming console. I could do that. So here's an example. And although I don't know for reals if this is how they do it. So for example, I'm a PlayStation gamer, and I have access to my PlayStation account on my mobile device, my game console, and my web browser. I assume, although I couldn't be sure, I assume that Sony has split up these front ends and are using APIs. So some kind of backend API to make this visible on all these platforms, because that would be a scenario where it's easy to do. So I mean, you could extend it well beyond that as well. So now let's take a look at Java backend. I've said several times already, this is a Spring Boot application. So we actually have a properties file. In this properties file, of course, I only have one node running, and that's my local node. My bucket is RESTful sample. I don't have a password on this bucket. You don't need a password, especially for prototyping. You don't need one, but you can set one if you want. So the first part of the application, there's actually endpoints, and this is all the back end right now. This is all the Java stuff and the Couchbase stuff. So there's a set of endpoint functions, and there's a set of database functions. So starting with the endpoint functions, let's say this is a save endpoint. So if we want to save data, so we'd be accepting this data through a post request. We'd be expecting that a JSON body is sent in this post request. And when we parse out this JSON body, we're checking for different properties. So the first property we check for is, does the first name exist? If the first name does not exist, or it's blank, we're going to return an error to the front end. Whatever called it, we're going to return an error to it. We're going to do that same check for not only the first name, but we're also going to do that same check for the last name. as well as the email address. And then provided that all of them succeeded, then we can call this static class database the save function. And we're going to see that class soon. But we can call the save function to pass in the JSON data along with our bucket, the bucket that we have open. Here's another endpoint. This one, let's say we want to get a particular document. So this would be a GET request, and we're providing a document ID. We're checking to make sure that document ID exists. Otherwise, we can return an error. If there's no error, we can call the get by document ID function. So you're going to see a trend here. So this is the delete endpoint. This is the last slide I'm going to show you on the subject. But you can see that every one of these endpoint functions I've modeled in the same way, and this is good for code clarity. It makes it very easy to maintain. So again, this one's going to be a post request. It could be easily a different kind of request, but we'll just use post for here. It expects a JSON body. As long as the document ID exists in that body, we can call the delete function of this database class. So here's a function. We're going to use it as a helper function. This is part of the actual database class here. You've seen this in another slide already, but I've broken it up into its own function. This is what we're going to use. So every time we get a result set, we're going to pass it into this function to parse it out into a list of maps. That's really all this does, and it's to really cut down our code. So here's our, this is actually one of our database functions. It's no longer an endpoint. So this is what our endpoint calls. This is save. The first line here that we're doing is we're checking to see if an optional document ID was passed in with our JSON data. If that document ID exists, if it's not blank, we're going to go ahead and use it. If it does not exist, we're going to generate a unique ID. We're doing this so that way we can actually do an upsert. So if you're not familiar with upsert, upsert is a create if it doesn't exist or replace if it does exist. So we're kind of hitting two birds with one stone here. Again, we're using a parameterized query. So we have 4 parameters, and we're creating a JSON array with those 4 parameters in order. And then we're executing this query. Again, it's synchronous, and we're parsing the results in the exact extract result or throw. Again, here's what it would look like in the database. I showed you this already, but just to rehash on it. Now for the get function that we created, that get endpoint. So in this case, we only passed in a document ID. We're going to create a select statement. We're selecting 3 properties from the bucket name that we pass. We're aliasing it as users, but remember, we're not storing the document ID inside. Sorry, I got a message. Sorry, we're not storing the document ID inside of the document itself. We're actually so what we have to do is we actually have to look at the metadata about the document. So the document ID is inside of the meta, and we can actually do our comparison against that parameter. Again, a parameterized query to prevent an injection attack. We execute that query, and we parse out the result. So again, just like with our endpoint functions, we're actually seeing a trend here. There's a similarity between our database functions. So again, this is the delete function, pretty much the same as what we already saw. This time, instead of select query, we're doing a delete. And so on and so forth. So just to rehash, the endpoint functions, all they're doing is data validation. They're validating what comes in and what comes out. The database functions, all they're doing is passing queries to Couchbase Server. So now let's look at the AngularJS front end. I'm only going to show a few slides on this because I actually do want to show you inside the code itself because there's not a whole lot that can fit on a slide. But here's an example of a function that I didn't show you. So this would be a function that queries to get all endpoints. So this would populate the list screen. So we're making use of the AngularJS HTTP service. We're calling a GET request, And provided that that request was successful, we didn't return any kind of 400 error or any kind of error message. We're actually going to loop through that result set. We're going to add those result items to the application scope. And that application scope can then be rendered to your front end, to the front end screen. Here's an endpoint that we did see. This is for saving. So again, we're using the HTTP service. This time we're doing a post request. We're hitting the create endpoint, which I think we may have actually called it save, but let's just call it create here. And we're passing in JSON data. So anything in this data parameter is going to be a JSON body. We're passing in first name, last name, email, and then we're also passing in this optional document ID. So state params will actually take the information from the URL bar. If that URL, if that information is null, our backend will then generate a unique ID for us, so we don't have to worry. Before I jump into the asynchronous stuff, I'll show you some code. All right, so this is actually the application I have up running. I'll skim through it real quick, starting with our functions here. I just skipped over a lot of the Spring Boot bootstrapping code, but here's that get all endpoint. It was very simple endpoint. Our get, delete, save. Why I'm showing you this is I'm showing you that I've basically copied this code into my slides, and I'm not trying to trick you. If I look at this database class and scroll into it, again, here's the get all function that get all endpoint calls. It's a standard select statement. It just selects everything from our bucket. We could do the same with get by document ID, delete. Again, there's no tricks. I just copied all this, and it's actually very clean inside of my application. What is a little different is the front end code. So this app.js file, I actually took it from my front end. And the one thing I didn't mention about the front end is the convenience of another convenience about splitting it up is you don't have to bundle it within your application. You don't have to compile it into your WAR file or anything like that. You can keep them independent. If I wanted to, I could host this AngularJS application on Amazon S3 if I wanted to. It's up to you. But I'll go over this slightly. So there's a configuration which sets up our routes. So this is actually a single page application that uses partials to kind of simulate a multi-page application. But what really matters is our controller. So we have our main controller. And inside of our main controller, all we're doing is we're doing a lot of different HTTP requests. There's really no independent logic inside of this AngularJS application. It's all HTTP requests against the server. And that's another added benefit of working with APIs instead of having to do all of that parsing and manipulation client side. So if I jump back into my slides, so that was all synchronous. So if you wanted to, you can actually use RxJava with Couchbase. So there is an async method, and that allows you to expose, of course, RxJava and work with observables. And with observables, you can then do different kind of transformations, combinations, filtering, stuff like that. So for example, let's say we have this function. The first part of it is we're calling, of course, the async method, and we're getting a particular document by its key. That's going to return an observable of type JSON document. But what we want to do is we want to then transform that into a different type. So we don't want to work with JSON documents in the end. So what we can do is we can make use of the map function. We can take our initial JSON document, extract a particular property from that document, and now we're working with an observable of type string. And at that point, we can then subscribe that the observable has notified us, and we can print it out. So in this case, we're just printing out hello and then whatever the name is. So that's all I have on the RxJava stuff. RxJava is a huge topic. it's best saved for another presentation. But it's just a taste on what you can do with Arc, Java, and Couchbase. So that was so far up till now. We've done mostly server stuff. Now I'm going to take a turn and we're going to talk about mobile. I'm going to be throwing different examples at you, so it's not going to be a continuation on our example that I just showed you. It's going to be a completely different example, but it's going to be working with Java and Android, and it's going to show you the rest of Couchbase and this full stack. So Couchbase Mobile is actually split up into 3 parts. So you have Couchbase Lite, which is your locally running database. You have Couchbase Sync Gateway, which handles the synchronization between the third component, which is Couchbase Server. So Sync Gateway will actually synchronize data between devices and Couchbase Server. So starting with Couchbase Lite, so it's a full-featured, lightweight, native embedded database that's JSON format. It lets you work with JSON data. It's available for different platforms, so you could use it for Android applications, you could use it for iOS applications. If you want to use Xamarin, you could use it for Xamarin. There's a whole lot of different devices that it supports. Of course, I even mentioned that I use it for an IoT project. So if your application supports Java, you could use Couchbase Lite in any Java application as well. The Sync Gateway handles, of course, synchronization. It's secure, so you can do various forms of authentication and authorization. You can set read and write access permissions. You can do a whole lot of good stuff around that. And then, of course, Couchbase Server is the highly scalable cloud server, which allows you to keep track of all your data. So more on Couchbase Lite. So again, it's a NoSQL mobile embedded database. It actually runs in process. So when you embed it within your application and your application starts, it starts its own little web server. So if you wanted to, if you didn't want to use the SDK APIs, you could actually do RESTful requests against it. It also allows you to do peer-to-peer because you can have other peers connect to you. We won't talk about that in this particular presentation, but it is available. It also has a small footprint, so when you install it within your application, it only takes up about 500 kilobytes of space, so it's not particularly large. Nobody likes large plugins in their application because it becomes really large to download, eats up a lot of bandwidth. Nobody likes that. So what does it take to get Couchbase Lite inside of our Android application? So first of all, we're working with an Android context. So we have our application context, and we're passing this into a Couchbase manager. So when we start this Couchbase manager, we can then open a particular database. So we would call get database. In this case, our database is kitchen sink. We would then, so if the database doesn't exist, we'll create it. Otherwise, it'll open it. In both scenarios, it'll open it. Once we have an open database, we can then create a document to insert. So our first thing we want to do is we want to create a map of objects. So we'll call this properties, and this will then be converted into JSON when we save it. But for this example, we have one property. The property is called foo. The value of that property is bar. When we create the document and call put properties, it is now saved into Couchbase Lite. So it's all local at this point. I'll let you know when we start getting into the server stuff, but this is all local right now. So you want to query for those documents that you've inserted. You can create MapReduce views inside of your mobile application. This would be the same MapReduce views that you create server-side as well, except for server-side you're doing this with JavaScript. With Couchbase Lite, you're doing it with whatever native language you're using, whether that be Objective-C, Java, C#, whatever. The results are persisted for fast query, and since you're working with a MapReduce function, it allows you to add breakpoints that help you better debug your application. So this is what it would take to get a view in your application. So we're creating a view called items by date. And it's important that you don't confuse this with a relational database view. I know that it's very easy because relational databases have views and Couchbase has views. They're very different. So we have this view, and now we create our map function. The goal of our map function is to emit key value pairs. In this case, we're only emitting key value pairs based on the existence of a created at property. So as long as our documents contain a created at property and it's not null, we're going to emit a key value pair. The key is going to be that created at timestamp. The value is going to be null. A lot of times, this won't be the scenario. A lot of times, at least when I develop these mobile applications, the value that I return is the document itself, so that way I can actually mess around with the document contents. But you can make these map reduced views very complex. This is just a very simple example, but you can make them very complex. And then once you create it, you can then create the query. You can set the sorting, and then finally you run it. So when it comes to querying your view, nobody wants to continuously query their views to see if their data has changed. Instead, you want to use change listeners. So you can actually listen for these changes, and it cuts down a lot of cruft code because you're no longer continuously querying, and you're able to listen for particular changes. So maybe you want to see if any document inside of your database has changed. You can create that kind of listener. Maybe you want to see if any document within your query has changed, so narrow it down. Maybe you want to see changes in replication status, or maybe you want to check to see if a particular document has changed. I don't know, maybe you have a document that represents users in your application. You want to see if a new user was created, or whatever it may be. You can check for changes on that. If you want to create a change listener, it would look like this. In this case, this would be a document change listener. So for a particular document, provided this document has changed, we're going to see if there was a conflict. So when you're working with Couchbase Lite, Couchbase Mobile in general, you're probably going to have many mobile devices included in your system. Maybe they're all trying to access and change the same document at the same time. Maybe they're all offline, and then they all make changes to this document, and then when they come online, that change is synchronized. We can actually check to see if there was a conflict, and then we could do some business logic to see which one should win. We could also check to see if the document was deleted, or so on and so forth. In terms of sync gateways offers full multi-master replication. It has the ability to minimize your battery drain, which I'll show you in just a second. And then, of course, change notifications and conflict detection. So when you're developing these mobile applications, you don't really care as a developer what's happening as far as sync, and that's good because all of these changes are actually going to be synced offline. You're going to be working with your local copy. The synchronization stuff happens in the background, and you don't have to worry about it. So here's what it would take to make your application sync friendly. So we saw all of the Couchbase Lite stuff. Now we're including sync gateway into the mix. So we're creating a push and a pull replication, and we're providing a sync gateway URL. You don't have to do a push and a pull. You could do one, you could do the other, you can do both. It all depends on your business logic. You can also set to see if it's going to sync continuously. So this is where I mentioned about battery drain. Maybe your application needs to sync continuously for as long as it's open, or maybe you want to set continuous to false and only synchronize when your application opens, or maybe when you do a pull to refresh. That is up to you and the needs of your application. You can also define authentication. In this case, we're doing basic authentication, username and password. You could do Facebook, you could do persona. There's a mix of options you can do as far as authentication. We're adding a change listener, and then we're starting the replication process, and it will do its own thing. And it'll handle any kind of network performance issues. It will handle maybe you don't have internet connection. So you could do all of your stuff locally, and then as soon as the internet connection is available, it'll start syncing for you. So Couchbase, as far as getting Couchbase Lite, you have many different options. You could use JCenter, you can use Maven Central, you can use Couchbase.com, you can use GitHub. So I tend, when I'm developing my Android applications, I usually use Gradle, which uses the Maven Central repository. So it's whatever your preference is. So I'm actually going to show you a Couchbase mobile demo now. So let me exit out of here. First, let me show you. So Couchbase Sync Gateway actually has its own little administration dashboard. I'm showing you this because I don't have Sync Gateway hooked up to my Couchbase Lite database. It doesn't need to be. So for prototyping, Sync Gateway actually offers an in-memory database, which erases when you shut it off. That's fine for prototyping. It's fine for my needs right now. So I actually have this database called To-Dos. It's running in the background here. Right now, there's no data in it yet. If I scroll over, I have 2 Android simulators running. So if I wanted to, I could boot up an iOS simulator as well. But since this is a virtual jug, I figured Java would make the most sense for Android. So if I open up this application, so I have the same application opened on both of these simulators. 2 different simulators, 2 different versions of Android. What I'm going to do first is I'm going to say add a new to-do list item, wash car. You can see my Sync Gateway is doing stuff in the background there, but it already synchronized it to the other simulator. And most of the time it's faster than what you just saw locally on my machine, but I have a lot of different things running right now, but it's synchronized. So if I scroll back over to the Sync Gateway dashboard and refresh, it's actually saved it so that way I can look at it. If I had hooked it up to Couchbase Server, it would also exist in a bucket as well. So it saves it with the property. I only have one property that I saved, and then some information about the document itself. So a revision. Every time I do a new save, the revision will change, and then the document ID. So now let's go ahead and add another one. I've just added another document, and it's already synchronized. I don't have change filters built into this demo Android application. So let's go ahead and see about making a change inside the dashboard to simulate it. So I don't live in a house, I live in an apartment. So I'm going to save it here, save the document. You can see the revision has increased, and it's actually synchronized this change to my simulators as well. Now, if I wanted to say delete an item, it's deleted it from both simulators. So it's a very cool system. If I go back into my slides here. So this is just a recap. So what is Couchbase? Couchbase is an open source set of database tools. So you have Couchbase Server, and you have Couchbase Lite and Couchbase Sync Gateway. All were designed to be very fast. You're working with schemaless data, and it's incredibly useful when it comes to enterprise. Here's a little chart on comparisons between Couchbase and other databases, including relational databases. I won't go through these, but this is recorded, and I'll even send Simon my slide deck, so this could be further evaluated after the fact. If you want to look at any of the demos, so we actually have a few demos here. The first one is the one that I showed you. If you want to get more complex, you can look at TryCB Java, which is also a server-side application, or you can look at more mobile applications inside of the Mini-Hacks repository. When it comes to getting help, you can go to developer.couchbase.com. You can check out our blog, which has plenty of tutorials. It's great for tutorials. I write tutorials there all the time. You can reach out to us on Twitter. the forums or Stack Overflow, or if you'd like to reach out to me personally, remember, my name is @nraboy on Twitter. I'm very responsive on Twitter, so I encourage you to reach out to me there. That is actually all as part of my presentation, and I'm happy to take any kind of questions at this point. I'll stop sharing my screen.
Awesome, thanks very much, Nick. And when you mentioned data stacks on that slide a couple ago, presumably that's Cassandra.
Correct.
Okay, right, cool. So we've got we've got a few questions in, and if anyone does have any further questions, in fact, let me ping in IRC right now. Any final questions? And those on IRC will be able to see the delay we have. Okay, any final questions? Right, so we've got a few questions. Right, first one then from Gaurav Brills 14. Are there any options to do transactional scenarios like shopping carts with distributed Couchbase?
So with NoSQL, transactions are not as important as they are in relational databases because with relational databases, the need to normalize your data is a lot stronger. So in Couchbase and NoSQL in general, you don't need to normalize your data. Copies and denormalized data is perfectly acceptable, but you can define certain optimistic locking to best fit your needs.
Do you find that with NoSQL style databases, because the data is distributed differently, you have fewer kind of deadlock scenarios and things like that?
I think so. I mean, I personally haven't run into any of these issues. I do plenty of development. Whether or not customers have run into this, not too sure on that, but I could always find out. I want to say no, though.
Okay. A question coming in from Code Monkey: can Couchbase import relational tables and reconfigure the data structure?
Yeah, so there's plenty of scripts out there. I did a blog post on this recently. So if you want to say come from a Oracle database or MySQL, there's actually a importer. It actually uses JDBC, the JDBC driver. It'll take your tables, each row of that table, and dump it into a Couchbase JSON document. So it'll be very flat, but most of the time that's perfectly fine because, like I said earlier, you could do a referred approach. You could embed keys to other documents inside of your document, and then use Nickel. You could do joins, and you could do all of that great stuff that you would typically do in SQL.
Okay, so it's really into that NoSQL world, and then you can pretty much create your structure from there.
Yeah, I mean, and if you didn't want to use that JDBC script, you could do more exotic things, like maybe you want to include Spark to read from, say, whatever relational database you're using and immediately dump it into Couchbase because there's a Spark connector. You can use data frames for that.
Okay. We have another question from Nikatsa. How does Couchbase guarantee that the data will be eventually written to disk? What if, while in memory, the process crashes?
Can you repeat that? I lost half of that question.
Sorry. How can Couchbase guarantee the data will eventually be written to disk? What if, while in memory, the process crashes?
Yeah, so that's a good question. So you can actually define this inside of the Java SDK. So you might have caught a glimpse of it in my code, but you can actually define whether or not to wait to see if it's been replicated, or you can define to wait to see if it's persisted, or if maybe it doesn't. If you don't care, you can get a response as soon as it's hit the cache. So you can define this based on your needs.
Okay, so you can either just like leave it there ready to sync, or you can actually kind of like force it. So
yeah.
you know, by the time you come back from that block, you know at that point it's been written, and you can carry on.
Yeah, exactly. And I mean, it's really dependent on the needs of your application, which one you choose.
Okay, cool. One other question about from Zakaria. Can you tell about the main differences between Couchbase and Mongo? A question which probably many are quite keen to understand.
Yeah, so I get this a lot, and I do want to not do any bashing or anything, so I want to keep it minimal. But so one of the big things that people experience why they switch from Mongo to Couchbase, and I actually did a podcast interviewing somebody who did this switch. They actually find it to be a problem when it comes to scaling. So at a certain point, when they're building up their Mongo cluster, it gets kind of out of control with the configuration. So they switch over to Couchbase, the single node architecture, and it becomes a lot easier. The other benefits that you see with Couchbase is the ability to do these NoSQL queries. So it's a familiar SQL language, which Mongo has their own querying technologies, but it's not as convenient. The third major difference is Couchbase has the caching layer built in. So with Mongo, you would typically install Redis or something else on top of it.
Okay, actually, yeah, you mentioned that kind of familiar query language. That's presumably because people are coming from an SQL world, right?
Yeah, and this is just a major assumption that I've made here on this virtual jug. I've done other Java meetups in the past, and the common thing is that many Java developers are using a relational database. Not all. I mean, plenty are using NoSQL, but I figured it'd be more familiar to many who are listening right now.
So yeah, I mean, so Satish on IRC says, is SQL mandatory or generic method? Are generic methods also available?
No, so you don't have to use NoSQL. You could, of course, use the MapReduce views, or you can do the CRUD operations.
Okay, cool. And I think that's all the questions that we have. We have one interesting one from P. Durbin about whether he should use OSGI or Jigsaw, but that's a little off topic. Here's another one. Rohit Katkar is wondering if you have any sample projects or anything on Git that people can play around with.
Yeah, so the Couchbase Labs, very important labs, is basically all projects that developer advocates like myself and the community members have created around Couchbase. So it's loaded with useful examples and material.
Okay, perfect. We have another question from Snatch. I've found in many places that joins are a real or a really big problem maybe when working with huge amounts of data. How does Couchbase solve this problem, providing the possibility of running joins?
Yeah, so with Couchbase, you're actually going to be creating indexes on your data. By standard, you have to have at least one index, which will probably be pretty slow if you only have one. So you'll be creating many indexes, and like I had mentioned in one of the slides, you can even create dedicated indexing nodes in your cluster. And this you can, of course, add more query nodes as well, and the combination of the two will allow for faster querying.
Okay, awesome. That's all the questions that we have right now. So what I'm going to quickly do is just share my screen again. And I just wanted to show if anyone wanted to follow Nic on Twitter again. There's at NRABOY, Raboy. So please do follow Nic on Twitter. And if you have any further questions or questions maybe you're thinking of during watching the replay, or if you weren't able to catch this live and you're watching the replay, do ping Nic on Twitter and ping him with any questions you have. Okay, coming up next, I'll come back to Nic in just a second, but before we end, coming up next we have I haven't updated the dates, but tomorrow we have Functional Programming in Java Part 1. Functional Programming in Java is actually a book which Venkat Subramaniam has created, and we're doing the book reading club, so there's actually going to be 2 parts on this. If you wanted this book, actually, if you go to the meetup site, you can find a code where you can get, I think it's maybe 30 or 50% off this book. So do check out that title. Obviously, it's from Venkat, so it's going to be amazing. And the next session after that, the next regular VJug session, is next week on Tuesday, I believe. And that is developing Java-based microservices with Kubernetes. So a lot of buzzwords there for everyone. And that is the speaker for that is Ray Tsang. And Ray is a developer advocate for Google, actually. So Ray works on the Kubernetes team. So a couple of really interesting sessions there coming up for everyone. Let me hit stop. Check if there are any other questions? No more questions. So, Nic, it has been a really, really great session. Thank you very much for your
Yeah,
time.
thanks for having me.
And it's a pleasure. Thank you very much. And your session is actually the replay is available now. So I'll tweet that and ping you, so you'll have that you can share.
Awesome.
And how was the session then, in terms of being a virtual webinar kind of thing?
It was good. Were you guys able to see me as I was going through the slides? I don't know if my camera was on.
No, not during the slides. During the slides, it full screens on your slides. Why? What were you doing, Nic?
Oh, you know, I was picking my nose and I don't know. just kidding.
No, it's yeah. Unfortunately, we can't do both, but just that, yeah.
No,
Okay, well,
good.
Nic, I'm glad you enjoyed it, and yeah, like I say to everyone, do connect with Nic on Twitter, and for now, thank you very, very much, Nic, and to everyone on the VJug, thanks very much for watching, and hope to see you on the next session. So, thanks very much. Bye.